Hello everyone, how are you all? Preeti, Chintu, Sahiti. Am I audible? Syam, Anu, Ruchi, Ananya, Anwar. Okay. So good morning everyone. Manish, Vishnu, Keshav. Okay. So what we studied in the last class, can you remind? We were studying the prediction of elements, I think. Na? Good morning everyone. We were studying the prediction of positions of element. Na? So we have done, I think, period we have predicted the block also, and then we were predicting the group. Okay, na? For the group, as far as I remember, we have told you about S block, P block, and D block also. Am I correct? F block was left, I think. Magic numbers we have done, correct. So after that, prediction is started, na? Achha, you were having paper also. How was the paper? F block completed. Shyam, good paper. Na? Easy one only. All of you were able to solve the questions. Chemistry 160. Achha, you got the marks also. Very good. Fine. Okay. So, what we wrote in the last class? So, I think we have discussed that F block also, and I told you for that shortcut from 104 to 118. 170, 165. Very good. Nice. Study nicely. Call your friends quickly so that we can start. Okay. Tell the group number for 117. What is the group number for 117? Do you know the answer? 17. 109. 117. Syam, 17. 109. Next question is 109. So last two digits we have to see. I told you clearly, for predicting, suppose they have given you any atomic number, first you think about what you will think about? You will think about F block. Check it for F block first. Okay, na? Then you check from 104 to something. Okay? Then you can do anything else. Okay? Acha, then I was telling like this also. See, this part is also there. Ki you can predict the elements. These are the conceptual things which we have studied. You can also predict the element just like a child. Like suppose you don't know all these concepts. Suppose you don't know all these concepts, then also you can try to tell the position of the element. How we can try to tell? See, this you can write also, you can skip also. This I'm just telling ki, acha, this is also one of the option. If we forget everything, then we can do this also. What we can do? Listen here. In periodic table, at regular interval, we know the atomic number at regular interval. See, like everyone knows the atomic number of noble gases. Do you know the atomic number of noble gases? Helium, neon, argon, krypton, xenon, radon. Then what is there? Ogneson. This is correct, na? Everyone knows the atomic number. What is the atomic number? 2, 10, 18, then 36, then 54, then 86, then we are having 118. So see, what I'm going to tell you now is, means I'm saying ki we don't require any concept, ठीक है ना? And simple, just like a child also you can predict the element. If you don't know about chemistry, normal people also, arts student can also tell, arts, commerce, ठीक है ना? How they can tell? So see, everyone knows the atomic number of noble gases. Now if they ask you, na, you just count it like a child. Like suppose they ask you 50. Suppose they ask you 50. Now everyone knows 54. So you can do like this: 53, 52, 51, 50. Got the point? 54, 53, 52, 51, 50. Now just count it back. This was 18th group. So this is 17, 16, 15, 14. Like this I am saying. ठीक है ना? For this I don't require any knowledge. Few elements we remember also. ठीक है? Like this. And period you can clearly say first, second, third, fourth, fifth period. Like this. ठीक है ना? Now what? We remember this also. You know 12. This is which group? 12th group. Which are the elements present here? Which are the elements present here? Zinc, cadmium, mercury, and what is this? The last one. Can you tell me what is this? The last one. Last one. After mercury, this is copernicium. What is this? Copernicium. Now see, everyone knows zinc is 30. Everyone knows zinc is 30. What is the magic number for D block except group 3? What is the magic number for this? Can you tell me? What is the magic number? 18, 32, 32. So what we are saying? 18. So add 18, so 48. Add 32, so 80. Then again add 32, 112, like this. Clear with this point? So now you can subtract from this side also. You can add from this side also. Like suppose anyone tells you 49. Don't worry. Now everyone remembers this. So you can clearly say that 49 is just after cadmium. This is 49. So what I mean to say, I just mean to say that periodic table, now we know many things. At regular interval, we know the groups. So just we can add and subtract also. Everyone knows this third group. What is this in third group? Batao, what is there? Third group, what is there? Scandium, then yttrium, then lanthanum, then actinium. So many times we have written all these things. So everyone remembers. This is your 89. Then we are having here titanium 22. Then we are having a zirconium 40. Then we are having here hafnium 72. Then we are having here rutherfordium RF 104. So if anyone asks you 73, you can tell quickly. This is your third period. This is your fourth period, sir. Fifth period. Sorry, third group, fourth group. You will say clearly fifth group. So are you getting the point? What I am trying to say here? All the concept is at one place. Okay, find how to find the period, group, period, highest quantum number, principal quantum number. Okay, fine, all these things. But just acting like a child, adding, subtracting, also we can do it. Because at regular interval, we are knowing the atomic number of the elements. Everyone knows this, 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 this. Now just keep adding, subtracting. If anyone asks you 29, 30 is there, subtract 1. 11th group, 4th period, D block. Understood the point? So you can just do like this also. So just a basic part we were trying to see. Now you can ignore it. Now let's start with the new topic. So from here you can say we will start periodic table nicely. Nicely means what? Conceptually. So the fact is, the definition is effective nuclear charge. Are you getting this point? Now we will start. Everyone call your friends Still 15 students missing around. ठीक है? So Z effective means what? We are saying effective nuclear charge. ठीक है ना? What do you mean by nuclear charge? Nuclear charge is what? Power of nucleus. Attraction of nucleus. Simple. Then what is effective? Effective, simple means resultant, final, net. ठीक है ना? Like suppose you sit for self study 5 hours. How many hours you sit for self study? बताओ, everyone tell your study hours. How many you do self study? How many hours you do self study? Write your numbers. Let me see. Suharshita. Okay, so everyone write your study hours once. Let me see how much time you are doing self study. Write it quickly. 5, 4, 3, 5, 4, Gopi 4, Dinesh 5, Vijay 3 hours only. Arey, 3 hours only. How you will do? Increase it into 16 hours. Okay, 4 hours, 5 hours, 10 hours, like this. So this I am saying your self-study hours. Clear? Now if I ask you the second question, effectively how many hours you are studying? Effectively how many hours of self-study? What you will say now? Ki sir, 5 I sit, 1 hour I use phone, 1 hour I talk. So effectively I do only 3 hours. Got the point? Effectively how many hours? Less, na? So that only this is there. Ki Z effective is something, you remove some point, final value Z effective. Clear? Okay. So see what we are trying to say. Suppose this is your nucleus. Okay, this is your nucleus having atomic number Z. Z also represents the protons. Clear? Now this is the orbit, for one orbit, second orbit, third orbit, fourth orbit, like this. Suppose there is only one electron E. Suppose there is only one electron E. Now, what are the forces which are existing here? Everyone see. What are the forces which are existing here? You will see only the attractive force. Attractive force. Which attractive force? Between the nucleus and the electron. There is no disturbance. One electron, one nucleus. Both are attracting each other. Done. So you can say like this, कि for single electron, there is no difference. Z effective you say, or you say Z, both are same. Only one type of force is existing. Which type of force you will say? Jaldi batao, which force is existing? सेंट्रीफ्यूगल सेंट्रीपिटल. चलो, हाँ ठीक है, फिजिक्स यू आर गोइंग ना. So we will simply say कि attractive force is there. We will say simply attractive force by the nucleus. Is it clear to everyone? देख लो एक बार. All of you can tell only attractive force is there. ठीक है? Done? Okay. Now suppose we have other electrons also, like one electron is here, one more electron is here, one electron is in his orbit only. Now what will happen? Some new forces will be there or not? Now suppose there are few more electrons, multiple electron system. We are talking about multiple electron system now. So what new forces will come? There will be repulsion also. Electron, electron, repulsion. Electron, electron, repulsion. Got the point? This electron also, electron, electron, repulsion. Clear? So now what is happening? Listen carefully. I am the nucleus. This is the electron, test electron. We call it what? Test electron. I am testing it. Mic testing, observed electron. I am doing experiment on him. ठीक है ना? Test electron. So what is happening here? Everyone see. Nucleus was attracting, but at the same time what happened? These electrons are pushing him back. Nucleus is attracting, but these electrons are pushing him away. So what will happen? Nuclear charge, nucleus pull will decrease or increase. Effective pull of nucleus will increase or decrease. Possible, Akhil. Just everyone tell quickly now. Electron was pulled by nucleus. These electrons are repelling the electron. So net pull of nucleus is increased or decreased. Everyone, write it quickly. So this is only known as effective nuclear charge, which is decreased due to these electrons. This sigma is called shielding constant or screening constant. Shielding constant or screening constant. Clear? So effective nuclear charge is a bit lesser. Why the effective nuclear charge decreased? If I ask you this question, why effective nuclear charge is less than the normal nuclear charge, what you will say? Everyone try to respond to this question. Why the effective nuclear charge is comparatively lesser than the normal? So you will say, sir, electron repulsion. Like suppose I am pulling you, come inside the room, and someone is pushing you, go away. Got the point? I am pulling you by 10 newtons. Other person pushing you by 3 newtons. My net attractive force will be what? How much? 7. So this is the reason. Clear? Got the point? Acha, due to the outer electron, suppose any electron is outside. So due to this, there is no problem. For this, sigma is 0. We can say like this. So we are considering only inner electron or the electron which is in the orbit. Clear with this point? Done. So this is all about effective nuclear charge. We can also say like this, these electrons, inner electrons, are shielding this outer electron. These inner electrons, see, I am not able to see the outer electron. These electrons, inner electrons, are shielding the outer electron. Clear with this point? Correct. F block, we said that only. Done with this one. Full F block is in group 3. Full F block is in group 3. So done with this point. Now we'll write some definition. First definition, we'll write what is shielding effect. Shielding effect or screening effect. Check it out. What we can write? The effect by which the test electron is, what you will say? Test electron is screened or shield, you can say, from the attractive, is shielded from the attractive force of nucleus. So the effect by which the test electron is shielded from the attractive force of nucleus. Nucleus is attracting, but someone is coming in between. Clear? So that is known as your shielding effect. Due to shielding effect, what is happening? Nuclear charge, effective nuclear charge is less. ठीक है ना, ड्यू टू shielding Z effective decreases. Now the question is, what is Z effective then? You can say the reduced nuclear charge. What is Z effective? The reduced nuclear charge experienced by the test electron. ठीक है ना, what is Z effective? Z effective is the reduced nuclear charge which is experienced by the test electron. Clear with this point? Till this point everything is clear. So we have seen two things, one is your shielding, second is Z effective. If only one electron is there, no problem, only attraction. If other electrons are there, then electronic repulsion also. Due to electronic repulsion, nuclear pull is decreased, which we call Z effective. Clear with this point? ठीक है? So this is all. Now you can also guess something. You just tell me this. Try to tell this. If I pull the electron, Z effective is more, size will decrease or increase? You tell one thing, everyone, listen this point. If Z effective is more, size will increase or decrease? Chintu, Ananya, all are saying decreases. Many students are there, but few are replying only. Everyone should reply. So now you understand what is the importance of Z effective. ठीक है ना? You can also relate Z effective with ionization energy, which we will study in future. ठीक है ना? चलो. So let's try to see this. Shielding effect order. You know shielding effect order? ठीक है ना? What is the order of shielding effect? Anyone can tell? Generally we write S is more than P, than D, than F. We write like this ना? ठीक है ना? But this is valid when N is constant. What is N? N is your principal quantum number. Orbit is fixed. Like we can say like this, ki 4s is more than 4p is more than 4d is more than 4f. So orbit I have fixed. Then whose shielding is best? S, then P, then D, then F. Understood the point? Understood the point? Now a simple question I am asking, okay? Simple question based on shielding only. Suppose you are watching a movie. You are sitting in the cinema hall, multiplex, and you are watching a movie. Everyone listen carefully. Z effective same from top to bottom, Kusuma. Okay, listen this point and everyone try to tell. Suppose you are sitting in a multiplex cinema hall. You are watching a movie, very good movie coming. Which movie is coming? Can you tell? Very good movie is coming. ठीक है? Kanchana 2. ठीक है? You are afraid. ठीक है ना? Now you tell कि screen is there, you are sitting here. ठीक है ना? And Kanchana 2 is there. ठीक है ना? You are very afraid. Which orbital you will keep in between the screen and yourself so that you are saved? Which orbital you will keep in between the screen and yourself so that you are saved from Kanchana? Your options are SPDF. Which orbital I will keep in between so that I am saved from Kanchana? S, P, D or F? Your options are like this. Are you getting the question? You are here, screen is there. Just imagine screen, Kanchana. Now I want one orbital which should be between the screen and me so that I am saved from the screen. So in this case, you require good shielding or bad shielding? You just tell this point, you require good shielding or bad shielding. Shield means a protective layer. Shield means a protective layer. Now what you will keep there? SPDF. So you will simply say, sir, S. If S is in between, I will be saved. If F is there, poor shielding. If F is there, Kanchana will come and will take you away. Understood? Shielding is very poor. Force is more. You are attracted, gone. Understood the point, everyone? Okay, na? So this is the role of shielding effect. Okay, so S is having best. Okay. If S is there, very good. Vijay is saying like this, ki sir, if S is there, then you cannot see the movie. Nice. Okay, na? Who wants to see the horror movie? Okay, na? So Vijay understood the point, what I am trying to say. Got the point? S is there, very good shielding. I am not able to see you also. Kanchana is also not able to see me. Okay? Okay. Acha, one more point is there. Suppose N is variable. This is first point. Second point is, suppose N is variable. N is variable. If N is variable, then what we say, you know, ki shielding is inversely proportional to N. What we say, ki as orbit increases, size of orbital increases. Suppose you are having 2s and 4s. Who is big orbital? Both are s. But who is big orbital? ठीक है ना? 4s is big orbital. Big orbital means so many empty space. ठीक है ना? So 2s shielding is more. Less orbit number, more shielding. Less orbit number, more shielding. Don't see sp now. Only see n. Only see n. Acha, Ganeshwar is asking one of the question of the listen, one doubt is there. Ganeshwar is asking one question from the test paper. The question was like this: ki Mendeleev periodic table, which element is not present and which element is present? And the answer will be none of these, because the options were like scandium, technetium, and germanium. All these were unknown. Mendeleev left spaces for these elements. He predicted, he was not knowing about this element. He said eka boron, which was scandium. He said eka manganese, which was technetium. So none of these three elements were present in Mendeleev periodic table. He was not knowing about them. Is this point clear to everyone? So from here, Z effective, the chapter starts. Everyone should not miss any class. If you miss the class, not my guarantee. If you attend all the classes, then you will get good marks. Clear? Okay? So got the point? Okay? Okay. So this is all about shielding effect. See, now there are two questions. One question is like this: ki shielding of 2s, 4s. And the second question is, who is more shielded by the inner electron? See, two questions are there. I will ask you. Like suppose one question is like this: ki which has more shielding power? And I am writing the options. Suppose you are having 2s. I am writing 2p, 4p, 6p. Which is having more shielding power? What you will say? Which is having more shielding power, screening power, shielding effect? So I'm talking about the property of this. So 2p will have best shielding power. Clear? There is one more question like this: which is more shielded? Listen the question carefully. First question is, I am talking about 2p, I am talking about 4p, I am talking about 6p. His power, 2p power, 4p power, 6p power. Second question is like this: which is more shielded by inner electrons? Listen the second question. Which is more shielded by the inner electrons? Again, the options are same: 2p, 4p, 6p. What you will say now? Who is more shielded by the inner electron? How you will tell? Now see, if you will, I'm not talking about 2p power, I'm talking about inner electrons. So before 2p you will have 2s and 1s, they will shield him. Before 4p you will have many, first orbit, second orbit, third orbit. Before 6p you will have again more, first orbit, second orbit, third orbit, fourth orbit, fifth orbit, all these things are there. So who is more shielded by inner electrons? 6p. So got the answer? I think everyone have understood because many people have written the answer 6p. Now come to the final question which they ask, which is in your material. They have asked like this, key, in which atom valence electron is more shielded by inner electron? And your options are sodium, potassium, rubidium, cesium. In which case valence electron is more shielded by inner electron? Everyone try it quickly. In which atom valence electron? What is his valence electron? 3s1. What is his valence electron? 4s1. What is his valence electron? 5s1. What is his valence electron? 6s1. So everyone is writing, everyone should write. Those people who are present in the class, everyone should write this. So you will say, sir, cesium 6s1 is more shielded by the inner. 1 is also there, 2 is also there, third orbit, fourth orbit, fifth orbit. So it is shielded by 5 orbits and their orbitals. Clear? All of you have understood? If you have understood, give a thumbs up quickly. So done with Z effective and all. Now we will finally write 2 points which you should remember. Either note karke we will write. What is the note? Done? So all of you understood. Very good, very good, very good. Okay? And reply, keep replying in class so that you are connected. One way class should not be there. I am saying you cannot say, so you write. Okay na? If you will not say, you will be lost somewhere. Okay na? Notifications are coming on your phone, you will jump to some other site. Okay? So keep saying, Vinay. Okay, so note 2 points are there. 1 point is like this, ki Z effective is almost same down the group. 1 point is this, almost same down the group. Generally we are saying for S and P. S and P block. Okay? And the second point is this, ki Z effective increases in a period. Done. 2 points we have to keep in mind. Ki in a period, Z effective is increasing. That's why size is decreasing. That's why size is decreasing. Got the point? Clear? Okay, nice. Now let's move forward. Come to the next heading now. Now we will study about the radius. Radius or the size part. Everyone see here? We will talk about the radius or the size part. Okay. So you will say, sir, very easy. Atoms are spherical. Just measure the radius of this sphere. Array, atoms are not like a football, na? It is visible. I will measure the radius. Array, 5 centimeter. Atoms are very small, not visible also by the naked eye. So it is very difficult to find the size, radius because it is very small. There is one more problem also. You know, it is difficult to find radius of atom. Why? Do you know why? See, what is there? Nucleus is there. Outside nucleus, electrons are there. Electrons moving. We say electron cloud. Now, when you see water cloud also up, there is no sharp boundary. बाउंड्री इज एग्जैक्टली नॉट डिफाइंड, ठीक है ना. व्हेन यू सी द क्लाउड इन द स्काई, बाउंड्री इज डिफाइंड? नो, इट इज डिफ्यूज्ड टाइप, ठीक है ना. Which are correct, but that is average thing, means everyone is not having same radius na, radius will change a bit. So what we are saying ki boundary, electron cloud boundary is not fixed, or it is not very sharp ki I have to take, it is not like this bracket ki I have to take till this point only, ठीक है ना. Cloud boundary, just think about the boundary of the cloud, ठीक है ना. So what we will say कि boundary of as boundary of electron cloud, not what, not sharp, not fixed, ठीक है ना. So that's why it is difficult to find the radius. So then what we will do, we'll stop finding? No, we'll find some methods. So they are very advanced methods. Spectroscopy they have written in NCERT by which they find the radius, ठीक है ना. Now what, there are many types of radius, like I will give you few examples. Metallic radius, ठीक है ना. Then they will say covalent radius, ठीक है. Then they will say van der Waal radius, ठीक है. They will say ionic radius, like this. Now NCERT considers, why you are telling so many names to me? NCERT considers metallic radius, both are atomic radius, both are atomic radius. Done, ठीक है. Now let's see what is happening. When we will talk about metallic radius, we'll take some metals like iron, cobalt, Ag, Au. I will take one atom of iron, other atom of iron, touch them together. See everyone on the board, touch them together. Now what you will do, connect their nucleus. So this is known as D. What is D here? बताओ D को क्या बोलेगा? Internuclear distance. Clear with this point? Now can you tell me how I will get the radius? Metallic radius, how I will get? Everyone tell, how I will get the metallic radius? You will say, sir, no problem, do half D by 2. ठीक है ना. Sajid is writing correct, D by 2. Clear with this point? Okay, so ठीक है, nice, no problem. One sphere, other sphere, touch it by 2, you will get the radius. Okay, very good. Now come to the next part. Next part, what is there? You are taking covalent. Covalent means generally non-metals. Covalent means what? Generally non-metals. How covalent bond is formed? You will say the sharing of electron. How sharing is taking place? By overlapping. By what? Overlapping. Now check the distance. When you will check the distance, now this is your D, ठीक है ना. So R covalent is your D by 2. So suppose if I write this one D1, if I write this one D2, can you tell me which is small, D1 or D2? Which is small, D1 or D2? Which distance is small, this part or this part? Common sense. Now, sir, in the first part you were only touching. In the first part you were only touching. In the second part you overlapped. So the distance will decrease. Distance will decrease. So the radius will also decrease. Clear? Now what happens now? Ki more overlapping you will do. See, suppose I have done overlapping this much, then I did this much, then I did this much. More overlapping you will do, radius data will be lost. Wrong radius data you will get. Best radius data you get like this, half. Getting this point? More you overlap, radius value will decrease. Getting the point? So what? We consider only single bond length. single bond distance, you can say, or single bond length, you can say like this. ठीक है ना? So like this we are doing कि suppose you have to calculate. Acha, why you are taking single bond? You may ask na, sir, why single bond? Why not double bond and triple bond? Because as number of bonds will increase, suppose you have taken single bond, less overlapping, double bond, strong, more overlapping, triple bond, stronger, more overlapping. ठीक है ना? Radius data, much error. So we will consider only which bond? जल्दी बताओ. We will consider only single bond. ठीक है ना? Not double bond. So if I have to take nitrogen atom radius, I will take NN single bond length and I will put here D by 2. I will not take double bond. I will not prefer triple bond because in this bond length is decreasing. Got the point? So which bond you have to take? Only single bond. Acha, there is a question based on this also. I will ask you later on. ठीक है? Now come to van der Waals forces. Van der Waals radius. Sorry, van der Waals radius. So van der Waals radius is mainly, what you will say? बताओ. Mainly measured in what? बताओ जल्दी जल्दी. Everyone fill in the blanks. अरे Anwar is knowing. Very good, Anwar. Mainly measured in what? Noble gases. I am writing mainly, means you can measure other places also, but I am interested in noble gases. Clear? Okay. Now what? Noble gas, they generally cannot form covalent bond. Have you ever seen argon covalent bond? Huh? ऐसे? In dreams also you have seen like this. Argon covalent bond. Have you seen this one? Huh? Never. ठीक है ना? So they will not form bonds. They can only just come closer, not touching also exactly. ठीक है ना? They are just trying to come closer as much as they can. So this is one argon, this is second argon. Both are trying to come closer to each other. Like suppose now this is D3. Suppose this is D3. ठीक है? So what you will say कि R van der Waals is your D by 2, D3 by 2, whatever you write, doesn't matter much. ठीक है ना? Got the point? So now if I compare the radius, then which radius will be highest, biggest? Can you tell? Can you tell which radius will be biggest? So it will be your van der Waals radius. ठीक है ना? कहाँ गया? I will write R ना. R metallic, R van der Waals, R covalent. Is this clear? ठीक है ना? You can write D3 by 2 also. No one is going to, right? Doesn't matter these things. ठीक है ना? I am just writing D1, D2, D3 just to compare. ठीक है? D3 is highest. So van der Waals radius is biggest. Van der Waals radius is biggest. ठीक है ना? And van der Waals radius generally we measure in case of noble gases. So we say like this also, you know. We say like this also, if you will compare halogen and noble gases, they will write some places कि noble gas is bigger. Because in noble gas they are measuring van der Waals radius. And in halogen they have taken covalent radius, which should not be true. Means we should not do like this. ठीक है ना? If you want to compare covalent bond of both, compare van der Waals radius of both. But what you are doing? In one case you are taking van der Waals radius, and in the other case you are taking covalent radius, and then you are comparing. Then van der Waals will come big only, na? ठीक है ना? It is like this. See, if I ask you 2 meter and 90 centimeter, which one is bigger? 2 meter and 90 centimeter, which one is bigger? Huh? Hey Swati, ठीक है? So don't say like this, अरे sir 90 this is big. अरे who will check the units? Before comparing, you should keep the unit same. Keshav, 2 meter means 200 centimeter. ठीक है ना? So this is the logic ना. They keep on telling you, अरे answer is in joule, put R 8.314, don't use 0.0821, but you keep on doing. So units should be same. When we compare, units must be same. If you are comparing radius, then we should compare similar type of radius. Compare everyone's covalent, compares everyone metallic, but you are not doing that. You are comparing one metallic covalent and others van der Waal. So we should not do like this. But if anywhere this is given, they write this thing ki halogen covalent radius and noble gas van der Waal radius. So they say like this ki in a period size is decreasing till halogen and then increases. Because in halogen you have checked covalent, till halogen you have seen covalent, but in noble gas you have checked van der Waal. See, everyone try to see this. I'm giving you time. Take the screenshot. After this we'll move to other points. See these ones. If you are having any doubt, ask. Read all the points once. ठीक है? See all the points. Then we will move to next part. So this is important. They will ask you about these things. ठीक है? Clear with this point? Everyone say it. Whatever we have studied, जल्दी से देख लो. Done. Tomorrow Eid. Weekend syllabus will try to cover till ionization energy. ठीक ना? In advance. ठीक है? Enjoy. Okay. This side we don't know. It is a less chance that they will give you holiday. ठीक है? But few classes will be there. You are at home only. ठीक है ना? You can manage. Think about the people, those who are offline. ठीक है? Clear with this point? So we all know these things. Now come to the next part. What is the next part I am going to tell you? See, ionic radius is left. Ionic radius we have not studied. We'll study it later on. Now come to the next part. Factors. Factors affecting size. What do you know? Simple things are there. First point though everyone knows. Sir, periodic table, I will tell you. What you will tell me? Ki sir, in a period, size decreases. Why it decreases? Can you tell me? This is important, na? Why size decreases in a period? See, so we can say like this, ki as Z effective increases, we have written before na, Z effective in a period increases, down the group almost constant. Clear with this point? So as you are moving in a period, Z effective is increasing, size will decrease. Clear with this point? Okay. Down the group, what you will say? Size increases. Why size increases? Now don't say Z effective decreases. We have written ki Z effective is constant. What you will write here? Ki every time extra shell is added. Every time what is happening? Extra shell is added. Clear with this point? So first point everyone knows, I think. Come to the next one, Z effective and size. Inversely proportional or directly proportional? Everyone tell me the second point. Z effective and size. Directly proportional or inversely proportional? Batao. Z effective is more. Size is? Hand will go up or down. Side will decrease. So inversely proportional to size. Okay? Z effective increases. Nucleus is pulling. Size will decrease. Acha. Now let's see who is able to tell this answer. Let's see who is able to tell this answer. Let's see what you are writing, Srinivas. Cesium is more shielded by the inner electrons, so Z effective should be less for cesium. C. No, we don't say like that. See what is happening na? Ki electrons are increasing, but proton is also increasing na? Proton is also increasing. Pull is increasing, but at the same time size is also increasing. So pull neutralized. Let's talk about this thing, shielding. ठीक है ना? Shielding effect or shielding is directly or inversely proportional to size. बताओ. What about this third point? You think and then you tell. Shielding directly proportional or inversely proportional? Can we say like this? If shielding increases, that means size increases. Now you try to think this. Don't do just say ki haan, directly inversely. You think this is nucleus. Shield means this is my shield, the best shield in the world. This is my electron. Now you think, can nucleus pull the electron? No. Electron will move, size will increase. ठीक है ना? If shielding increases, electron can move anywhere. Size will increase. Good shield. Very good. Captain America. Captain America's shield. Electron is not in control. Size will increase. So this much we have to talk about. 3 points are there. 3 parameters are there. So keep this in mind. Most important parameter, this one. Don't say answer directly. First you think, then you tell. ठीक है? Clear with this point? देख लो जल्दी से सब लोग. After this we'll study a very easy point. Everyone knows, and generally questions are asked from there only. ठीक है ना? After this we'll study a very simple and important point. No reverse na? See, Z effective as shielding reverse. Good shielding means Z effective decreases. Z effective decreases. Z effective is pull off nucleus. Okay. Now we will study about ionic radius separately. ठीक है? Now come to ionic radius. Everyone see here. So first we will talk about cation. ठीक है? Everyone knows what is cation. Very good. Suppose I am comparing sodium and sodium plus. Can you tell me who is bigger? Can you tell me who is bigger, sodium or sodium plus? Simple, we can do like this. See, sodium 11 atomic number, this also 11 atomic number. So if I ask you proton, you will say, sir, same sir, same. If I ask electron, you will say, sir, here 11, but here it is 10. Is this point clear to everyone? देख लो एक बार. ठीक है? Done or not? So many were saying sodium, correct? Acha, you tell me one thing. Let's see this point. If Z, I have to reduce the size. You listen one point. I have to reduce the size. What I should do? If Z effective increases, size will decrease. And if repulsion increases, size will increase. You are understanding these 2 points? If Z effective increases, size will decrease. If electronic repulsion increases, size will increase. So due to repulsion, size increases. Do you agree with this point? That due to electronic repulsion, size will increase. Now see here. What we are seeing here, कि proton is same, but the electrons are less. If electrons are less, that means repulsion is more or less. Everyone tell quickly this point you have to tell. If electrons are less, electron number of electron decreases. That implies repulsion. What will happen to repulsion? Jaldi batao. Repulsion will also decrease. If repulsion will decrease, Z effective will increase. Size will decrease. So we can say cation is smaller than parent atom. So I will write here कि cation is dash than parent atom. Now you tell what I should write here. Cation is dash than parent atom. Everyone fill in the blanks. Cation is smaller than parent atom. Now you tell reverse. You can imagine like this also. 11 villain, 11 hero. ठीक है ना? Think like this. 11 villain, 11 hero. Tie. One hero reduced. Villain will dominate. ठीक है? So electron reduced, proton will dominate. Electron increased, electron will dominate. ठीक है? Come to the next part. Now we are talking about anion. Now you tell this, Cl or Cl minus, who is big? Cl or Cl minus, who is big? Big. Cl and Cl minus, who is big? बताओ. Cl minus. Let's talk about the proton. How many protons? 17. Here also how many? 17. Electron 17. But here it is 18. Electrons increased. What you will say? Number of electrons increased. That means repulsion. बोलो भाई repulsion क्या होगा? Repulsion also increased. That implies Z effective. That means Z effective will decrease. That implies size will increase. Clear with this point? Done. That's it. So what I will write here now? Which point I will write? Similar to this. इधर बताना मेरे को. Anions are dash than parent atom. Fill in the blanks. Everyone tell this quickly now. Anions are larger. Anions are larger than parent atom, bigger than parent atom. Clear? Okay, done. All of you are getting this point? Now finally we will summarize this. Can I say like this? कि size is directly proportional to negative charge. Can I say like this? देखो everyone. Can I say कि more negative charge, more size? Like suppose if I have M minus, M2 minus, M3 minus. Who is bigger? M3 minus. Can I write reverse of this? कि size is inversely proportional to positive charge. More positive means size decreases. Like suppose you have M plus, M2 plus, M3 plus. Size is decreasing. Are you getting this point? So this is my final conclusion. कि more negative charge, more size. Less negative charge, less size. More positive charge, less size. So you tell me final answer. Cl, Cl plus and Cl minus. ठीक है ना? What is the order? Who is the smallest? You tell in this, who is the smallest? Cl, Cl plus, Cl minus. Who is the smallest? Smallest. Nitisha, smallest. So Cl plus is smallest. Cation are small than parent atom. Anions are big than parent atom. Clear? Niharika, everyone correct. Vijay, Kiran, Keshav, Kavita. Understood? All of you understood these basic things? Done? Now we will move to the last point of this. What is the last point and the most important point? Isoelectronic spaces. Do you know isoelectronic spaces? Bolo, yes or no? What are isoelectronic spaces? Tell quickly. Same number of electrons. Very good. So here there is a single point. Many questions are asked from this. This year also, NEET 2023. Question asked on this. Okay? Do you remember the question? So we can simple say only one point is there. Size is inversely proportional to atomic number. Atomic number means what? Z. Atomic number means what? Don't say this tau. Okay? Atomic number means what? Z. Got the point? देख लो एक बार. Is it clear? ठीक है? So now you tell me कि N3 minus O2 minus Na plus Kmg2 plus Al3 plus all are having 10 electrons, isoelectronic. Who is biggest? Atomic number less, biggest. Am I correct? देख लो एक बार. Is this true? And I'm telling you again, periodic table has started from today only. You can think. ठीक है ना? Don't miss any lecture. If you miss the lecture, your problem will arise. Your problem will increase. ठीक है? So don't miss a single lecture. Revise daily. Practice questions. Got the point? So like this only, there was a question in NEET 2023. ठीक है ना? What was the question? They were saying like this कि which will be biggest if they attain noble gas configuration. So see, all are having noble gas configuration. So which one is biggest? N3 minus. ठीक है? Clear? So like this they ask the questions. Got the point? ठीक है? So whatever we studied till now, these are normal trends. These are normal trends. ठीक है? There are some exceptional points also. There are some exceptional points also. ठीक है? But before going in that exceptional point, I will write one more thing here. That is S block size. I will write S block elements size. ठीक है? This is just observation. You confirm this in next class कि size was correct or not. Okay. So see, I am writing like this. This is your lithium, sodium, potassium, rubidium, cesium, and here we are having beryllium, magnesium, calcium, strontium, barium. ठीक है? So there is a order like this given everywhere. You just see this order is correct or not. Okay, data is also in NCERT. You can verify. So beryllium is the smallest, then lithium, then magnesium, then sodium, then calcium. See, nice na? Order is nice. Then it is like this, N shape: calcium, strontium, barium. Then from barium you go sodium, potassium. Then from potassium you move to rubidium, and then from there you move to cesium. Is this correct? You go and verify it. Okay. So this is the way of remembering the order of size of S block elements. ठीक है ना? Interesting. ठीक है? So beryllium is smallest. You can tell also na कि in a period as we move it is small. So beryllium is small. Sodium, magnesium is small, like this. ठीक है? So you can go and check the data also. One more thing I am writing here: lithium and iodine. What do you think? Who will be big, lithium or iodine? Atom. I am talking about atom. Lithium atom and iodine atom. Which will be bigger? What do you think? Iodine, na? Everyone thinks iodine. Okay, but you go and check once the data. there is a graph made. In the graph you will get the data. ठीक है? So just go and check, you will find कि lithium is bigger, ठीक है ना, as compared to iodine. ठीक है ना? So check in NCERT you will get the data, where you will get graph is there. Graph is there. In that graph sizes are written, ठीक है ना, halogen size and alkali metal size is given. Clear to everyone? ठीक है? So enough with today's lecture. In the next class we will start with exceptional things. We will do the exceptional things and then we will do the ionization energy part over. Clear? 752 नहीं 152, ठीक है ना? In NCERT you go and check, this is written around 152 and this is written around 133. ठीक है? Clear? Got the point? ठीक है? So in the next class we will deal with the exceptional things and then we will move to ionization energy. Ionization energy, whatever we will study, that will be in the syllabus. Clear till this point, everyone? ठीक है? So enough for today. ठीक है? Hope you have understood everything. Revise the notes. If you are having any doubt, we can talk now. Okay? Attend the classes regularly. Don't miss any lecture. Any material you are having, you can solve questions from there. Any material you are having, you can solve questions from there. ठीक है? Okay. चलो ठीक है. हाँ, QR code you can take. See, this is the QR code. ठीक है? चलो ठीक है. Thanks everyone. Bye bye. Study nicely. Get selected. Become doctor. चलो. Bye.
So, good morning to everyone. I hope now it is okay. Voice is coming? Right, board is visible. That's great. So, let's start. So, I think many people went after the class, not returned till now. Right, very good morning, very good morning. So, up to where we discussed in the last class? Gynosium over. So, we have to start probably the placentation. Is it na? We have to start with which one? Placentation. Gynosium not over. Placentation. Sir, keep new live. So, should I go for end streaming and then live? What you are saying? Okay. End streaming. I am ending the streaming and otherwise all file will come together. I am ending the streaming and then going for live.